My name is Dave Terry. I work for a company called Pacific Data Management. I've been designing database systems for 25 years. I was introduced to Wakanda probably a couple of years ago, and I've been involved with helping to document it and kind of promote it in some ways, because I find it an absolutely fascinating product. I've done some documentation. I've done some webinars on data modeling, how you can use the Wakanda data model to your advantage, and I'm not probably going to go through a training class this time. So I think I'm actually been put on the beginner track, but this is going to be a lot more code-oriented and a lot more example-oriented. So what I want to show you is what you can do with the Wakanda data model. And I'm not going to show a whole lot of interface. I'm just going to focus on the models themselves and how you use them, okay? So to that end, I created a solution with a bunch of projects in it. Each one has its own model. And I'm going to just describe those and show you how they work, why they work, using all the tools. But before we do that, let me give you a little quick slideshow here. Let me give you some general advice. Before you begin doing a Wakanda data model, be aware of all your options. Try to figure out what they are. You know, there's a whole bunch of different tools, and if you leave one out, it'll make your life miserable as you're trying to work on your application. So, I mean, that means all the different security options, all the different tools, events, methods, data classes, all the different types of attributes, and so on. When you design your Wakanda model, as Dave pointed out very clearly, you want to include as much business logic as you can into your model. You want to make it so that that is really where everything happens, and you don't rely on the browser. You want to build security into your model at that level. You do not, absolutely do not want to rely on the browser for security. You'll get spoofed, something bad will happen. Restricting queries, Dave talked about that a little bit. Restricting queries are how you control access to individual entities per data class. So you're going to need to know about them. They are very powerful, and they have shown up in every single model I've done. Derived classes. I'm going to show a little bit about inheritance and derived classes. Derived classes give you a way of creating a user-specific view, if you want to think of it that way. There's all kinds of other things it does too. And then another piece of advice, you want to fill out your data classes. When you deliver an entity to the browser, all of its attributes go with it. And if all those attributes give you a complete picture of what you want to do with that entity, then you don't have to make another request to the server. And you can do whatever you need to do in the browser and then return the entity. And then the last thing I can give you as a piece of advice, look for data model examples. And I'm going to be showing some today. This solution is available on the Wakanda website in the best practices section, along with the document explaining these models. So that if you want to go look at it, try to understand how they function. I'm going to be updating it probably in the coming week, because I found some cool things I wanted to add. So we'll get to that. Wakanda, because the model is so integrated, it does so much for you, there's a certain creation order that it implies. You can't start doing things unless you've already got certain things. So let's just go through that real quickly. This is just how I generally do this. This is how I create them. First, I create all the data classes that I'm going to need that are really obvious. They got to be obvious. You know you're going to be dealing with invoices, people, and so on. You put them all up. Don't put any attributes in them. Make a decision right then and there whether or not you're going to swap the key out for a different kind of key. I use the Wakanda long int keys. They're fine for me. But some people might want a UUID. It's a good time to make that decision right then and there whether you're going to switch to a different kind of key for each of your different data classes. Then choose one of the main data classes, one of the ones you know for sure, and fill out all the obvious storage attributes. Those are really fields. So you fill them all out, get them down, get them named. You can even do some calculated attributes if they're really basic and they rely on the storage attributes. Fill that all out, get that done for one of your data classes, and then repeat that for all your data classes. Fill out the storage attributes and maybe the really basic calculated attributes. Then choose one of the child data classes, one of the ones that's at the bottom of the information hierarchy or at least is dependent on some parent data class, and start adding your relation attributes. I typically create my into one right at that point, I go ahead and say I'm going to go reference, if I'm a sales order, I'm referencing a customer, I create the attribute. And you do that for all your data classes. So you put in all your relation attributes. And when you're done with all that, then start adding the more specialized things like dependent relation attributes, which just follow a path, and alias attributes, which are kind of the same. They just follow a path. You can always add those later, but you can't add them until you've got your relation attributes, your primary ones. And after you've done all that, then start coding. Then start doing your events, your methods, and all the other stuff that make up a data model. Okay? So if you just follow that, it won't hurt you. You'll be in good standing. So I'm not going to get to all these examples today. I know that for sure. But I'm going to try to go through them fairly rapidly so I can just give you an idea of how these models work, why they work, how you would do things in Wakanday's data model. Okay, so I'm going to start with this project called Education. This is a data model that I designed to run a school. It's not a complete data model. It's not going to run a big school or anything, but it gives you the idea of what pieces you would need if you were running a school. Okay? So let me first just go through these data classes really quick. We got Course Master. Course Master is just the list of all the courses that this school could potentially give you, all the subjects, in other words. So, and it's just got basic storage attributes, code, name, department, units, and all that stuff. Very simple. Then we have courses. A course is an instance of a course master being given. So for instance, a course will have in it the schedule, Monday, Wednesday, and Friday, at a particular location, room 222, year and semester, and that's what makes up a course. A course is an instance of a course master being given at a particular time, particular location. And a teacher, the course teacher for this course, who's going to teach it. In our application, we're assuming there's only one teacher, but we're going to go with that for now. Then at the top here, we have a person data class. And this person data class is going to play a multitude of roles for me. Every single person associated with the school will be in the person data class. Everybody. That includes all the teachers, all the students, all the staff, anybody we're trying to mail things to, anything. If it's a person, it goes in this data class. And it'll play a couple of different roles. You see down here I have a couple of properties that I have set not to be public, so they're not going to be able to make it to the browser. And these are the things I'm using to log in. I'm going to use the login listener technique to log into this system, and I'm going to use one of my own data classes to authenticate who you are when you're trying to get into my system. You can tell that a student's going to need different capabilities when they get to the UI. They're going to need to be able to sign up for classes. Teachers need to be able to put in their grades for the students. And maybe the registrar needs to be able to, say, create a whole new semesters worth of courses. There's a lot of different users going into this system with different capabilities. Now you see over here I have two more data classes. These are derived from person. These are inherited data classes. And you see right here it says inherited from person. And what there are is I know that somewhere down the line in my UI, I'm going to need a list of teachers by themselves. Like for instance, if I'm assigning a teacher to a course. I don't want to assign somebody who's not a teacher to the course, right? And the same thing is true of students. I'm going to need a list of students somewhere down the line. So these are derived classes, and I'll show you how I make sure that only students show up in one, only teachers show up in the other in a second here, okay? Then the last thing you see down here is attendee. Attendee is, in essence, the joining data class between students and course. In essence, every one of these shows a student's taking a particular course, and its purpose is to show that, but that also capture the grade. And I'm going to capture the grade using grade point. Now, I wanted it to be numeric because later on I'm going to do a GPA. I need it numeric so I can calculate a GPA. So 3 for a B, 4 for an A, and so on. But sometimes you don't want to see 3 for a B, 4 for an A. You want the letter grade to show up. So I'm going to start some code example here with this attribute right here called grade. Grade is a calculated attribute, and its purpose is to show you the grade alphabetically. Let's just start with that. So here it is. How would you do something like that? Well, it's very simple. If you know a little bit about JavaScript, I'm defining an object which each of its properties is the numeric equivalent of the grade, and its value is the letter. And then all I'm doing is taking this grade, which is that particular grade, 3, 4, whatever it is, and returning the returning the grade. This object I could have created somewhere else and had it already ready, but I wanted to make sure it was in code so you could see it clearly here. Okay, well that's fine and dandy. Now that just means that anytime I want to see a grade, I can look at an A, I can look at a B instead of 3 and 4, okay? Well, but you can take calculated attributes a lot further. You can assign values to them and decide what you want to do with that. So here's the onset, which is fired when a value is assigned to a calculated attribute. And all I'm really doing is reversing the process. So if you assign the letter A, I turn that into a 4 in the grade point. Well, that's great. Now I can use either attribute for assigning. Maybe teachers want to put it in as B+, I don't know. So I don't have to worry about that. And I've taken this a little step further. I've actually implemented what's called the onQuery event. It's not an event. Well, the onQuery for a calculated attribute. And what I do is if you try to query the alphabetic equivalent, I turn that into a query on the grade point. Grade point's indexed, nice and fast. And the result, let me give you an example. Here I am. I'm just going to run some code on the server. I'm going to get the first 100 attendees, and I'm going to display to you the full name of the student, the grade point, and the grade. I got to log into the server. And here we go. So 2 is a C, 3 is a B, and so on. That works great. Nice and easy. If you don't want them to even get to the grade point, you could just hide that, and they would never even see it in the browser. But one of the huge advantages you get is it's a true attribute and can be queried on. So here I'm saying greater than B minus. Now that would have some bizarre meaning if it was an alphabetical thing, right? But no, I want it to be the true value. And there it is. So I redirected the query to the grade point itself, and it's nice and fast. You'll love calculated attributes. Fill them out, use them properly. If you overuse them, they can slow down your app, but I'm going to talk about that in a minute here too. So that's an example of a calculated attribute. Now, back up here to these two data classes I talked about, teacher and student. Okay? So these are derived from person, and you notice how they don't have as many attributes down here below. That's because I've removed some of the attributes I don't want to be in the teacher data class. It's very easy to do. I can show them to you real quickly here. See all the ones that are crossed out? That's just a matter of clicking on one and clicking a checkbox, and then they're not part of that data class. Okay? Now, how do I determine that somebody is a teacher? Well, I've decided the way I want to do it is a teacher is a person that teaches. That's all it is. So down over here, I'm going to go to teacher, look at my restricting query. Oh, that's really hard. Return a query out of people where the teaches equals true. That's it. So somebody in the registrar's office can set the teacher, a person to be a teacher, can also set them as a student. There's no conflict. They can be individually set, and they can become a part of whatever class you want them to become part of. You control it at the data level. Okay? Now, right now you can't.
You used a single equals. Is there a reason you guys chose to use query type?
Yes, Laurent, is there a reason? Because it was confusing to everybody else.
Yeah, it's confusing. You can also use the double equal.
Yeah.
It will work also. It's just I'm lazy. When I type, I like to type once.
What it is you're seeing text in the query language. There is no assignment in the query language. So equals and double equals are equivalent. So if you're used to using double equals, you can use double equals. Well, the question is it for speed's sake that I'm doing this? It's primarily for UI usage later on. I want it to be that I can show a list of teachers and never make a mistake about what I'm showing you and accidentally include somebody that isn't a teacher in that list. And somebody else might be able to set whether they're a teacher or not me, but at least when I pick things, I can't go wrong. Okay?
The same thing be achieved by if you don't have as part of your query the teacher attribute and the person.
Okay, so the question is, why not just do queries on the person table? Well, because where would you do that query? That query would typically end up being on the browser side. Now, if it's on the browser side, we all know it can be spoofed. So we don't want it to be able to be spoofed. What I'm showing you is ways to make sure that the result is you can't get around my model, is really what it is. Okay, so now let's go through. You can't, hold on, just let me go. I got so much to get through. I'll answer questions in the break after this, okay? Teachers. Teachers have certain things about them. Right now in a derived class, you cannot add storage attributes. That is going to be allowed in the future, but it's not happening right now. But you notice up here, I've added a couple other calculated, a relation attribute and a calculated attribute. Has taught is just very simple. It's a calculated attribute where, oh crap, I just erased it. Well, let's go to registered, same kind of thing here. Attendance length is greater than 0. That's the calculated attribute for showing whether a student is registered. Well, what does that mean? Registered just means that they are attending, they have some attendee entities related to them. And if they do, then they are in attendance of the school. Very simple. GPA. Let's look how GPA is calculated. Wow, that's really hard. Look into attendance and average the grade point. Very simple. It's not that hard to put together a lot of pieces that you would use as building blocks later on. Okay? Let's see. Let's go for... Now, you've seen, if you haven't seen a login listener, let me just give you a real quick picture of a login listener so you know what it is. It's a method that you write that intercepts the authentication call into Wakanday server. It sits between the directory and the browser. That's its job. And its job is to authenticate the user. And I'm not going to go through this because I'm going to do this in the security session, but fundamentally, the things you want to pay attention to is this right down here. See this storage attribute for what you're returning? Whatever you put in there will be automatically transported into the session storage of the new session. So here's your opportunity to set up what this user can do and any other little bits of information that are going to make your application work correctly. Okay? So now, let's go on to the next one. That's education. You can download these and look through all the code and stuff if you want. I'm not going to save anything. Let's look at sales. Now, I come from the business world where I've written a lot of database custom applications. So everything looks to me like it's for a business. So here I've got a sales model. And this is a typical model you might use to fulfill customer orders. Okay? So the goal is we want to make sure that we can sell stuff to a customer, track how much we charge them, make sure they pay us, that kind of thing. But it has one twist, and the twist is it supports customer-specific pricing per product. Okay, so that's the goal of this model. It's going to show you a tricky ability, and it's going to show you how easy it is to implement. Okay, so first let's start with contact. Contact is an individual. That's just a person, or really what we're really trying to capture there is an address. And you notice that it has a relation attribute to customer. Okay, so a contact belongs to a customer. The reciprocal of that is down here, contacts. So if you go back the relation, you go back using contacts. Now, in the customer, we also have two other contact references. Okay, and the goal is these are the default billing contact and shipping contact for the customer. That makes sense. And when we assign a customer to a sales order, we want to copy the default billing contact and shipping contact out of it into the sales order. Something we always did in databases. It's not that big of a deal. Okay. Now, the first thing I want you to notice is notice how contact does not have all of the reciprocal one-to-N relationships back to billing contact, shipping contact, billing contact, shipping contact. That is showing you that you need not keep your one-to-N relations if you don't want to. If you're not going to use them, we'll kind of create some for you automatically. If you're not going to use them, just delete them. They're just clutter up your model if you're not going to be using them that way. Okay? So down here we have, okay, so sales order. Let's continue with sales order. So let's look at what we would do if we assigned a customer to the sales order. Remember, I'm on the back end here, not the front end. So customer, onset. Onset is the event that happens when you assign a value to something in an entity. Here it is. Now, the user may have assigned a value to billing contact and shipping contact. So I don't want to overwrite it if they assigned it. I only want to overwrite it if they didn't. So I want to copy the copies out of customer if they didn't assign it. Well, that's easy. There's a new function that's available in Walk 3 called Get Modified Attributes. It returns an array of the names of the attributes that have been modified in this entity. How easy is that? So all I do is make sure that they didn't assign the billing contact. If they didn't do it, then I'm going to do it, and that's what I do. I assign the billing contact. Very easy. Built into the model, back end happens, doesn't have to worry about what's going on the front end. Okay? Now let's look at a sales order itself. A sales order, let's say our rules are that when you write down a sales order, you have a bunch of things that you have to check. For instance, I don't want them to assign a billing contact that is not one of the contacts for the customer you assigned to the order. Right? That would be weird. You can't do that. I'm not going to let you do that. And maybe some other rules. The way you handle validating an order is through the onValidate event. Okay, so when you want to control, there's two different events you get. There's onValidate and onSave. OnValidate's purpose, its intention is for you to examine the entity and make sure it qualifies to be saved. And the onSave event is really designed, it's intended for the busy work that goes with saving. So you want the onValidate to happen, and you want it to just verify that this entity is valid, or return an error and say what's invalid about it, basically. I don't like this entity. So let's look at real quick an onValidate here. Okay, so the way you control this is if you return an error, which is not really an error, it's just a specific JavaScript object that Wakanday is expecting. If it has an error property that is numeric and not 0, then it's an error. That's really how it works. So I always start off with no error. That's the equivalent of no error. And then I go through some work. And the work really is just very simple. Was there a customer? Was there a billing contact? Was there a shipping? And all. And then down here you see, I look into the customer. I look through their contacts. I do a find on it looking for a specific billing contact, the one that's assigned to this sales order. And if it doesn't show up anything, then that's illegal, because that means you gave me a contact that was not from that customer. Very easy, done in one line of code, one query, and then I throw a different error. That's it. That's validation. That's all you're really doing in validation. You're piling up what's wrong with the entity. Okay? Let's see. Now, in this example, in this system, one of the tricky things that I found is how do you save an order and save its items at the same time? So let's go through the rest of these data classes real quickly. Here we have sales items. You see that it references a sales order. So basically you can have a bunch of sales items on a sales order. The main things you want to pay attention to are the price and the quantity. Really, you're just trying to sell stuff. And of course, it references the product being sold. And over here we have the product. And the product is just whatever it is we sell. And it has a list price. Think of that as like the manufacturer's suggested retail price. But over here we have another data class called customer price. And its purpose is to allow for customer-specific pricing on particular products. So what does it have? Well, in essence, it's a joining data class to customer, to product. It has a price, and it even has an effective date. So it's not even effective until a certain date and so on. So this is kind of, this is starting to look a little hard to deal with here. How do we pick the right date, the right price for our part, and how hard is that going to be? I'll show you that. Now, the last thing I'm going to do is, what I'm going to show you next is, let's say our business rules say we need to save the order and the items all at once. We don't want there to be a sales order with no items, and we certainly don't want sales items to be orphaned and have no sales order. Well, in Wakanday, you can save them independently, right? On the browser, you could say save the sales order, save the sales item. You may not want it to be able to be done that way. Say in our business, we say you can only save new orders. You can't change them. We're not going to allow you to change them. And we're going to save them all together as one thing. I'm going to show you a method and explain how it functions so it could show you how to do that. This method is intended to be called from the browser. So here it is. It's just called Save New Order. It's an entity level method, so it's attached to a particular sales order. You'd create a new one on the server. You fill it, on the browser. You'd fill it all out, and then you would do this. You would call this method, and this method expects a parameter called sales items. Okay, and I go through some work here to make sure that sales items is what I think it is. And only thing I'm going to pay attention to in sales item is nothing to do with price, just the product ID and the quantity. That's all I'm going to pay attention to because I don't want to trust the browser's price. I don't know if they spoofed it or not. So for instance, here's sales items. Now the first thing you see here is I put it into a JavaScript try catch block. That's just a great big bundle of code where if anything goes wrong, it goes down to another piece of code. Okay? And in here, the very first thing I do is I validate the entity. Well, if that validation fails, it'll throw an error, and my try will catch it, and then the rest of this is unimportant because the sales order doesn't look right. But if it does, I do a bunch of tests, right? Is it not new? Well, if it's not new, that means I'm modifying one. I'm going to throw an error. Sales items, is it null? I just go through all these things. I'm basically examining the parameter, make sure it's appropriate. And if it makes all those criteria, then I start a transaction. Okay? Transaction, just a bundle of modifications that can be written all at once or rejected all at once. Then what I do, I cycle through the sales items. That's all I'm doing. And in essence, after checking to make sure there really is a product and everything, I'm writing a sales item down for each one of those elements that was passed to me. The sales order is going to be the one that I'm in right now. Quantity, the product, which I just determined up here with a query, and so on. And then over here you see the product, get customer price, passing in the sales order. Well, let's go look at that. Get customer price is a thing to calculate what is the proper price. So here it is down here. It's an entity level method. I'm going to look at the code there. And here it is. Sales order is being passed in. The keyword this in this case is the product. So I'm going to get its customer prices. Well, that's all the customer's prices, not just the one that's for this order. I get the customer out of the order, I get the order date out of the order, and I construct a query string, right? Customer is this, effective date is less than this, which is the order date, so that makes sense, right? It has to have already been effective to get that price. And then I order by the effective date descending, because there could have been more than one effective, and I use the Wakanday find. Find only finds the first entity that matches the criteria. And as a result, if find returns not null, then I've got a customer price. Otherwise, I give them kind of a consolation price here, list price minus list price and the customer discount. All handled as an entity level method on the back end, can't be spoofed. That's its purpose here. Let's see. I think that's enough on the sales model. Okay. Now, those were simple. I used to work in manufacturing a long time ago, and I have worked on manufacturing bill of materials systems. Bill of materials are, in manufacturing you have this concept where you have something you sell and it has parts within it. And some of those parts within it might be also something you sell and they might have parts within it, and so on. And it becomes this recursive nightmare to manage these things, okay? You know what I'm talking about, right? You see something like this exploded diagram, and then you zoom in on one of those parts and it's got parts, and then you zoom in on one of those and they got parts. I wanted to see how Wakanday would handle something this difficult, because I've worked on systems in the past that I've had to actually do this. So I created a model for this. Now, this is just the heart of it. It's not the whole manufacturing system. And there are certain needs that we're going to have to handle in this model, right? You have to track all your products. Everything that you possibly can sell, everything you could possibly keep in inventory, and every single assembly in between. You have to keep track of all that stuff. Okay? And that's what the product data class is. That is anything that we could physically hold in our hand, it's going to go in this list. Okay? And there are a couple of different needs that we're going to need to produce out of this, which is we're going to need to know, is this a product that we make or is this a product that we buy? You might buy nuts and bolts and stuff, and you might make a microwave. Okay? But the microwave might be made up of nuts and bolts that you bought. Okay? So we have the idea of make or buy. We have the idea of cost of goods. Cost of goods is just simply a roll-up for any given product. How far down the chain do we have to go to calculate all these parts, how many things are in it, rolling it all the way up to the top to determine how much it costs us really in materials. Okay? Kind of hard to do. Quantity can make is another thing that you typically need to know. How many, given our current inventory, can we make of any given thing? Right? Yes, we can make 4 of these because we have enough parts to make them. Okay? And then there's a need at the very end called an exploded bill of materials, which is a view that's kind of like that graphical view I showed, but for all the indented parts all the way down. Okay? So now how do I do all that stuff with 2 data classes? First, I have product, and I have another data class called component. Product is everything we own or can own. And you see in here it has some really basic things. It has a buy cost. So if this is something we purchase, how much does it cost? And it has a quantity on hand. How many do we have in inventory? So we got 20 of these, and it costs us $3 to buy them. Okay? Then it also has composed of. What is it composed of? If it's composed of something, what are its parts? Well, I use another data class called component. And the reason I need another data class is because there may be a quantity of these things that it's part of. And what it does is I have a composed of these components, each of which points back to a different product. So it's recursive. It's not a true recursive relation, but it is recursive in its nature. Okay? And I wanted to see how hard would it be to do some of the typical things you need to do. Let's look at something like is assembly. That's basically telling us if it's an assembly, it's something we make. Oh, sorry. If it's not an assembly, it's something we buy. Let's look at how we would do that in a calculated attribute. Well, that's pretty easy. This composed of length is greater than 0. Okay, well, that's pretty easy. How hard is that? Then I said, okay, well, another thing I need to know is how deep is the bill of materials for any given product? How far down does it go? You know, I mean, you might have a microwave, and then in there's a motor, and the motor might have other parts. And how far down do we go? Well, that's depth. Okay? And let's see how hard it would be to calculate depth on the fly. Well, if it's not an assembly, I'm going to return 1. So if it's something we buy, it's a 1. If it's assembly, then what I want is I want to look into the composed of and get the max of the product depth. Well, let's go look at product depth in component. Product depth is just an alias attribute back over to product. No code. This runs recursively, automatically calculating the depth. Let's see that happen. Here we go. I'm going to look at the first 100 products, look up their code, their depth, and their name. This was just now calculated live. Here's a 4-part one, went all the way down the chain and back up to figure out how far it was. Actually, depth is an attribute. We can query on it. Everything depth greater than 2. All the 3s and 4s and so on. I kept it at 4. I didn't want to go too far down. Okay, so there you go, an example of how elegant you can make a very sophisticated task in the Wakanday data model. Let's go further. Let's show you something really serious now. Cost of goods. We used to have to do this in a batch job at night. Okay? I'm going to show it to you, and it's going to run live. Here's cost of goods. Here's the code on get. Well, what's it do? Once again, it needs to know if it's an assembly. If it's an assembly, if it's not an assembly, it's just going to return the buy cost. That makes sense, right? Because if it's something we buy then. Otherwise, I'm going to look into composed of and some extended. Well, what's extended? Go over here to extended. Sorry, let's get rid of this. Extended, also a calculated attribute. Well, what does it say? Well, it's really just going to multiply the cost times the quantity, but where did it get the cost? It got the cost from its product's cost of goods, which then fires its children, which then fires its children all the way down the line. Let's see that happen. Here we go. Calculated live, $1,995 for this audio, I made up things, okay. Audio snake. So that went down, determined how many components, brought it all the data back up, and it returned it instantly. And this is on the back end, but this information, once it's done calculating, can be easily delivered to the front end. Okay? Let's do one more. Let's look at quantity can make. Very similar. Quantity can make. How many can we make given our current quantity on hand of all the things that go into this? Let's go down and look. So here we are. I'm going to start assuming it's 0 if it's not an assembly. You can't make something you buy. Okay, that makes sense, I guess. So that's going to be 0. Otherwise, if it's an assembly, then I'm going to do the minimum of max can make. The minimum, because one of those components is going to be the gating factor for me. I can't make more than that. So if I go down here and I look at max can make, also a calculated attribute, here it is. Return, well, I do some work to make it look like sense, but fundamentally what it is I look at its product's quantity total. Well, what's quantity total? Quantity total, also calculated attribute, very simple. It's just the quantity in hand plus the quantity I can make. And around it goes, calculating it down, each one individually, all the way down the chain. Let's see that happen. And here it is, doing cost of goods, depth, and quantity can make live. Now, let me caution you. This is an extreme use of calculated attributes, obviously. You will often decide between whether you're going to be doing things in calculated attributes or the same thing in methods. Methods have an advantage that you control when they happen. Calculated attributes, who typically only fire when you try to access them, the problem is when an entity is delivered to the browser, you're accessing them, so it needs to calculate them for the browser. So you'll often want to struggle between which ones you want to use. Attributes can be bound to widgets and can become columns and stuff. There's a lot of things you can do with attributes. You can query on them. There's a lot of power to them. But methods, you have the opportunity to make sure that something doesn't slow down your application. You can only fire it when you need to, and you may want to use... You're often going to want to struggle with that, and I haven't really came up with a great rule when you want to do it and when you don't want to do it. Okay? Okay, one more thing I'll show you real quickly. The last thing you want to do typically in this kind of application is show a bill of materials, an indented bill of materials. Okay, so here you go. Okay, so I wrote a method. It's on the entity, and what it does is it just returns a complex JavaScript object. That's all it does, and it returns it, and then I go through some formatting so you can see it nice and pretty. But for instance, over here, if you look at this grid, it's got cost of goods being calculated for all 3,065 and depth. I'm going to sort on that. I'm going to sort on depth. Okay, so this is me going, I want the top ones to be the 4s, so I want to go over here and click on something. And there is the indented bill. So this thing up here, Audio Snake, has a 5449 and a red. I don't know why. And it has product, it has things in it, and it has things in it, and all the way down the line. Very, very easy. And I did, by the way, I did exploded usage too, just in case, the opposite direction. What is my product used in the reverse direction? Okay, so there's an example. This This entire solution is available on the Wakanda website under the best practices section. So if you want to get a hold of this, and there's a document there that explains it all, shows you how you would do all these things. Okay, now let me show you one more. How are we doing? Awesome. Perfect. That's perfect. Okay, so the guys back at work tell me this one's the hardest one to understand, so I saved it for last. Okay, now whereas the last thing I showed you had a recursive-like nature to it, this actually has a recursive relation. You know, almost every database I've ever written has a people table in it somewhere, right? I mean, you almost always are tracking people along with whatever else you're tracking. And that's what this is. This is meant to be my I called it employee, but it's my people data class, okay? And it's, you know, a typical data class. It has a bunch of, you know, first, middle, last, photo, you know, all kinds of things in it. That's fine. I'm going to use it for login, and so I got the login and password secure. And then the only really interesting thing down here that you get to is this, manager. Well, my manager is another employee. So all I did is reference the same data class. And then, of course, Wakanda created the reciprocal for me, which is if I'm a manager, my direct reports, who reports to me. And that's what these are. These automatically will get you to your parent data through your information hierarchy very, very easily. Okay, so let me show you this real quickly. We've done this kind of thing before, so I don't want to stick on this very much. But here we are. I'm going to look up the first 100 employees, and then I'm going to get their full name and their title, and then their manager's full name and their manager's title. Okay, so it returns that information easily. If this was, you know, the toArray function is available also on the browser, so you can, or you could even construct an object and hand it back to the browser, however you want to do it. Notice how the top guy, Bill Costa, who's the CEO, he doesn't have a manager. That makes sense. But all these other people do. Well, because these are just attributes, I can use them in queries. So I can say something like, find me all the employees whose manager's last name starts with an M. So that ought to get some of these people, if they have managers that start with M. And there are, see McGuire, you know, all the way down the list. Okay. Well, that's really cool. That's very useful. But look at this. You can also do this. Let's go the other direction. I want to find all the employees who have a direct report whose last name starts with M. So that's going the other direction down the relation. There they are. But let's be sure of that. What we'll do is we'll actually show the direct report's last name. And there are. See, this M, that's how they got qualified to show up here. So that's a recursive relation. Incredibly elegant, very easy to use in Wakanda. You know, I've always been afraid of recursive relations because I've always, like, you know, been lost in them. It's so easy to use them in Wakanda now, so they really work well. Now let's keep going here. Let's go back to this model. Now, what is this model's purpose? I wanted to create a system where employees could make evaluations of other employees. That was my goal. I wanted it to be that you can say something anonymously about your peers, about your boss, and about your direct reports. I don't want it to be that you can talk about anybody in the company. I just want to keep it constrained to the people that you normally would be able to deal with on a day-by-day basis. And so to that end, I created these other two data classes. So let me show you those real quick. First, I have evaluation. That's really simple. It's just a data class by an employee, about an employee that has some comments. Now, that's all I did with my evaluation, but it could have been much more substantial. Okay? So, and I don't want people to know who wrote them. So I've already set my by employee attribute to be public on server. That means it can't get to the browser. No one can figure it out. Okay? Now, if I can't do that, then how am I going to be able to get to this data class and fill it out correctly? So what I did is I created another data class that's derived from employee. So this is inherited. And I hid a bunch of attributes I don't want to have on there. And the purpose of this data class is that its goal is to show you only your peers, your manager, and your direct reports. So this thing is going to be contextual. It's only going to it's going to change what it produces based on who you are. Okay, that's its job. And the way you're going to do that is with a restricting query. So here's my restricting query. Okay, and there's a couple of tools. The main thing you want to pay attention to is your session and your session storage. I put some information into the session during my login listener. I identified who I was and who my manager was. And now this code is relying on that. And each user that authenticates gets a session. So you don't have to count on, you don't have to try to track things. You can be assured that this session goes with the person who's making this request. Okay, here we go. What does a restricting query do? It returns an entity collection. That's its job. If it returns nothing, that's a valid entity collection. I mean, an empty entity collection is a valid return. That's legitimate. In fact, that's what I always do. I always start with, give me an empty collection and return that collection if anything goes wrong. Okay? Easy to do. Now, the rest of this is I try to get some information out of session storage, and if that information's not available, I'm not going to let you see anything then. If that information is available, I then start checking some things. The current session, is the current session one of the admin users, part of the admin group? This is really, you almost always want to give yourself a way out for like an admin user. This is inappropriate in this particular case because this is a derived class. That would be way more appropriate if I put a restricting query onto a base class. Okay? Now, the rest of this is just the busy work I need to do here. I look to see, as long as my employee ID is there, then I also check to see is my manager ID there, and I just build a query string. And the query string is very simple. Is the ID my manager's ID, or is the manager ID my manager ID? That means that we both have the same manager, but not me, and ID is not me, so I don't want to make comments on myself. Or manager ID is my employee ID. Now those are going to be my direct reports. And I'll show you this working. It's very elegant, very easy, contextual changes on the fly. Now, the next thing is, you see over here I have two calculated attributes that I've added. Okay? The first one is called relation. And all I want to do is I want this code to return, is the person my manager, my report, or my peer? That's all its purpose is. And it uses the same information out of session storage to do that. Okay? Very simple. It's just going to return manager, report, or peer based on the situation. Over here, evaluation comments. This is what's interesting. Evaluation comments is a calculated attribute, but it doesn't try to get the information from something inside of WorkMate. It gets the information from evaluation. So what this means is I've created a calculated attribute that itself is contextual. It will return the evaluation based on who the workmate is and the person logged in. And that's what this code does. It returns the evaluation comments. The reverse of that is if you set something in it, it writes it to evaluation, an entire another data class. So let's see this whole thing work. I created a little web page to see this. Okay, so I'm going to log in, and I'm going to log in as the CEO. Oh, yeah, basic login. I don't do much. And it's got photos and stuff that are nonsensical. Okay, so I'm logged in. Up here you see Bill Costa, CEO. And then here's his, in his particular case, he only has reports because he doesn't have any peers. So you've got Karen Murphy, and each of these persons is a vice president of something. This is just bogus data. Okay, so. And then down here you see Grant Ritchie, and Grant Ritchie has a comment. And I'm going to change it to went to Wakanday, okay, and save it. And now what that did is it, through that calculated attribute, wrote it to an entirely different data class. But if we log out, and log in as a different user. I'm going to go in as one of the vice presidents. Now you see the relation is being calculated. That is that calculated attribute that tells me what they are. My manager is Bill Costa. That makes sense. I'm in as vice president of support, Karen Murphy. And down here you see Grant Ritchie again. And notice there is no comment. That's because that calculated attribute was figuring out what to show under the circumstances. And in this particular case, I haven't put anything in yet for this. Okay? Now, the last thing I want to show you, I think I'm making good time. The last thing I want to show you is an org chart, right? We got all this hierarchical employee information. How would you use that? So I did something similar to the bill of materials system, where I calculated everybody's, the people that report to me, and then I gave it a way of controlling the depth of that object. So for instance here, if I'm on the group leader, here's his reports. If I'm on the CEO, these are my direct reports, but that's because I'm only down 2 levels. If I want, I can bump that up and look deeper. And you can look at this code, how this runs, if you want to download the example. And then this is just a fancy formatting for an object on the browser. Okay, so now, does anybody have any questions? Neil.
I noticed there is a restricting query as an attribute and also as an event.
Yeah.
What are the differences and when do you use each one?
Okay, so the question is, there's both an on-restricting query event and there's an attribute in the model where you just have where you have just a restricting query. Let me show you the difference. Okay, so here, you see over here it also has a place for restricting query. Okay, so there, first off, if you put both, they'll both run. Okay, let's go with that. I suggest you pick one. This thing over here can be faster because you write it in the Wakanday syntax for querying, right? So it's just a string. And it is faster because it's built directly into the definition of the class. Okay? But it's inflexible because you don't get to change it. And it's very hard to make it contextual. So your on-restricting query event can run your code and can make it so that you can change what they see based on things. So for instance, in the data model I showed at the beginning for teachers and for students, I could easily have just done it there. I personally prefer the on-restricting query mechanism because it's easier to notice it amongst all the other things. If you put it in here, it works really well, it's very fast, but I kind of like them grouped together all doing one thing. And so I just got used to doing the on-restricting query event. Other questions?
Can you set up like unique constraints on an attribute and also like foreign key constraints? Can you do that?
Well, there are a lot of different properties you can do. I don't think that there's the hard and fast foreign key restraint that you get out of a SQL database, is there?
No.
No. You would handle it yourself because there is a lot of, you have an opportunity to do almost anything you want on the back end and control it how you want to do it. So no, there's not really that concept of the foreign key constraint. You would typically do all your work in the validation code and decide what you want to have happen as a result of that. So you would say, oh, you didn't assign this, or you didn't give me any children, then I'm not going to let this be saved, right? It's more that you're working in objects than a traditional database. And Wakanday server, when it delivers objects, even to the server, when the core engine, what it delivers are JavaScript objects. So it makes it so that it's very clear when you start working with them. It's the same way you're going to deal with them on the browser. They're almost the same thing even. You have to change how you think about it, really, is what it is.
The unrestricted query that you were just talking about versus actually using it at the table of data store level, what triggers this unrestricted query?
Okay, the unrestricting query, in essence, replaces all entity access. So think of it as the equivalent of what you're going to get out of all. So if you say ds.employee.all, that is what's going to come out of the restricting query. But it also applies when you try to access individual entities, when you do fines, everything. Basically, you can't get to entities that don't meet that criteria.
Where did you place it? Where did you place the unrestricted query?
It's in the unrestricting query event.
Oh, that's in its own event. Oh, okay. Got it.
Anybody else? Questions? Wow, awesome. And thank you for coming.